Hello everyone, welcome back. So this is the day 2 of our SQL series. So let's recap what we have go through on this day 1. So on day 1 we have gone through the data and what are the types of the data that we have and databases, types of the databases and what is an SQL and how it was as a language and how it works. So today we are going to discuss about the file systems and the database management system and introduction to our data warehouse and RDBMS, relational database management system, and what are the different types of keys and entities and relationships between them, and what is the architecture of SQL, and what are the different kinds of interfaces, and what are the types of SQL that we platforms that we have. So we are going to discuss about all these things. Let's get started. So what is a file system and what is a database management system? So basically a file system, it's a way of arranging the files, consider as a folder. It has a list of files which are grouped into a category, and this file system basically it operates like you can rename the file and you can give access file to someone, you can delete a file like this. So you just have manipulation things in file system. So there are some examples of this file system. You might have heard about the anti-FS system and ext. So people who are using the Windows, they might know about these things. So this what is this anti-FS system? So anti-FS system is a new technology file system. So that means it's a hierarchical system. So each folder is divided into subfolder, and subfolder is subdivided into again files. So there will be a files, there will be user directory, and there will be a master directory. So this is how this file system works. uh, so it's pretty simple, right? So and then coming to the database management system. So what is a database management system? So database management system, it's basically a software. So that's collects the different types of data and storing them and retrieving or extracting the data whenever it is necessary, right? So it provides a proper security as well. It provides a proper security, and it protects the data. Mostly it protects the data from unauthorized access, right? So this database management system, data can be fetched, it can be fetched from a SQL queries. Whatever the query you write, you get the data from here. So this that's not the case for a file system, right? So examples, so there are clear examples of this database management system. So we have this Oracle, and we have this SQL Server and MySQL and Sybase. So these are all the examples of this database management system. So why we need this database management system, and what are the advantages over this file system? So the first point that we need to discuss is about the structure, how the files are stored, right? So and then the data redundancy. So in file system, maybe in file system there might be a duplicates, or a same file might exist in different name. You have the same contents of the data. So but in DBMS we can eliminate that. We can eliminate the redundancy, that is duplicates. So and backup and recovery. So whenever there is a failure, the file system is not able to recover all these files. But in the RDBMS there is a backup, there is a tools, and even if it is lost we can recover the database. That is how it works. And query processing, there is no such efficient query processing in traditional system, but we have in database management system we have better query processing system. And there is a consistency. We have consistent data in database management system. And regarding cost, obviously the cost of maintaining the database management system is more, but it gives us a better organized system, right? So in this file system, it was very less compared to the database management system. It's very less expensive. So and then user access. So user access, so this database management system, multiple users can access this database at the same time, whereas in file management system, you can only one user can access the file at one time. So there is a limitation. So and again, sharing, how the data can be shared. So this data will be distributed in many files, so it's quite difficult to share these things. But in database management system, there is this centralized system which enables us to share the data very easily, right? So these are the major systems, differences between the database management system and the file system, right? So we will get started into our next topic. Yeah, so let's get into our next topic. So if you have any queries on your previous topic, feel free to comment. I will answer all your comments, and feel free to add your questions and go through with the topics what we have discussed every day. Okay, so our next topic is data warehouse. So what is a data warehouse? So let's imagine we have a company that has data coming from different websites, different sales, applications, and different customer support systems in different formats. So let us say we have data source 1, data source 2, and data source 3. Like, so you need to bring all this data into a centralized version. I mean, you need to collect all this data. So just like an example of a shopping, you shop your cosmetics one place, you shop your vegetables one place, you shop your clothes one place, but finally you bring all of this together into your house. The same way, it's the data warehouse. That is the data warehouse. It's the simple answer. How you bring all these things together to make some better decisions, right? To make use of the data. It's a data warehouse. It's a centralized storage system that collects the data, and it stores and it manages not only small amounts, a huge amount of data from terabytes to petabytes, right? So which will be further utilized for analysis and reporting. So why? What is the main purpose of this data house? It's just not like we are doing for daily transactional for banking systems. It's not only for that. It is also designed for analysis, reporting, and decision making. And when we use the data warehouse for our daily transactions, it is called OLTP. And when we use this for reporting and decisions, it is called OLAP. So we will go through about these terms in our next sections, right? So how it works, how the data warehousing works. So data from various systems which is extracted, and we know that not every data will be in the same format. So we format the data, we clean the data, and we transform the data into our required format, and then we load it into our data warehouse. Once you store this into our data warehouse, our analyst, our next level persons will they will utilize this data and prepare a powerful reports like analytics, reporting, and data mining. So it may be the current data, it may be the future data as well, and historical data as well. So why we need this data warehouse? So without this data warehouse, this a lot of data, right? A lot of data, it looks scattered and it might be inconsistent, which leads to slow reporting, and you're not able to make your decisions faster, and it may be prone to our errors. With the data warehouse, with this particular data warehouse, you can get clean data, centralized data, and the data that can be queried. So that we will be used for other systems, right? So that is the main reason that we have a data warehouse in our companies or wherever it may be. So, and then again, what is this data marts and what is this metadata, right? So these data marts, we can say the data mart is a subset of warehouse. And what is metadata? So metadata, usually this metadata refers to the data mart's data. I mean, so it refers to the structure, content, and management of the data that is stored in the data marts. So it basically helps the users and systems to locate and manage the data very efficiently, right? So there are different kinds of metadata, so which we will be discussing broad in a broad way in another topic. So because it's a big subject, and how we are using this metadata, like this. So we will be going further. So let's get started into our next topic: relational database management system. So what is relational database management system? We know about the database management system, and now we are going into the relational database management system. So what is this relational database management system? So in RDBMS, it stores the data in the form of tables. So you know table like an Excel spreadsheet, you have rows and you have columns, and it defines the relationship between one object and another object. So here the object we refer to a table, right? So this RDBMS defines how these tables are connected to each other. So that is why it is referred as relational database management system. So a clear example I'm gonna give is on the customer. So let us say there is a customer table with columns like, let's say you have the customer ID, you have the customer name, and you have the customer email, and then we have order table. So there we have the order ID and the customer ID and the amount. So if you observe these two tables, basically you have the customer ID common in both of these two tables. It links these two tables, right? It links these two tables. So that is the relationship between these two tables, and it is powered by different types of keys. And this is how the different keys that we have. So there is a primary key, and there is a foreign key, and there is a candidate key, and secondary key, unique key, composite key, surrogate key, partial key, alternate key, and super key. And there is one more key, surrogate key. So majorly we use the primary key, foreign key, and surrogate key in most of our cases. All these other keys will be used based on the scenario and based on the requirement. So let's get started. So what is a primary key? What is a primary key? So it uniquely identifies each row in a table, right? So how you example, you have a you are working in a company and you are an employee. What identifies you as a different person? Not your name, because there might be same person with another name. So here they will give you an employee ID that uniquely identifies you from different person. See, and no employee will not have no employee will not be left without having the employee ID. So the main requirement of a primary key is it uniquely identifies each row of the table, That means it must be unique and it should not be null, or not. When you say null, it is not empty. So example is a customer ID or employee ID in a customer table or in employee table, right? So then what is a foreign key? Foreign key is it's a key that it connects from one table to another table. That means if you have an employee ID in here, and that employee ID will be referenced into another table. Like I said, example about the customers and orders table, right? So it creates the relationship between these two tables. And next, coming to this composite key. What is a composite key? So all this composite key can be used to uniquely identify a row. It may be a one column or a multiple columns. So there might be difference. So one becomes the primary key, and the rest of the keys will be the alternate keys, because they are part of unique combination, but they are not treated as primary key. So you have to remember that each table will be having only one primary key, right? So what is an alternate key? So this alternate key, it's nothing but it's a candidate key which is not chosen to be a primary key. Like example, so you have this employee table and you have this email and username. If you consider the username as unique primary key, and this email will be the alternate key, it doesn't mean that it's not a primary key. You have to have only one primary key in a table. The rest of the unique keys will be an alternate keys, right? So that is how this alternate key works. So then what is this super key? What is the super key? So any set of columns. So we have uniquely identify a row, use it to uniquely identify a row. Even a primary key may be a super key, but not every super key is like a candidate key. It sounds a little bit confusing, but it's clear. So a set of columns that are uniquely identify a row. So for example, if you see here, it's a primary key, it's a candidate key, and a super key. So candidate key and primary key are subsets of this primary key. And then what is a natural key? Okay, so this natural key is come from real world scenarios, like real data, like your SSN number or your PAN number or your Aadhaar number, like, or your phone number. So if the real world value change, it affects the integrity of this particular key. And then we have this surrogate key. What is a surrogate key? A surrogate key is an artificial key. So it's an auto incremented value. So you give 1, 2, 3, 4, 5, it's an auto incremented value. It doesn't mean that your table doesn't have duplicates, but it uniquely identifies each row, right? Instead of a natural key. Example, user ID. If you consider the user ID as an integer and you give the incrementing value 1, 2, 3 in the SQL server, so basically this surrogate key is used to improve the performance and flexibility, and mostly it avoids changes if real world value change. For example, if your SSN change, or if your email change, your phone number change, it is used to change the entire record, right? So what are the properties? So we not have this indexing will be the automatic by using this kind of keys, and there will be no redundancy, and you can enforce the values inside the table, right? And we have the referential integrity. That means one table, if you have a value in one table, the same value will be present in another table. That defines the relationship between these two tables, and it will be unique. So how which key will be used at which scenario? So we use primary and foreign keys to enforce our relationships between these two tables, right? And we use these surrogate keys for stability. Okay, so and one more important thing that we have to remember is we have to stop using, I mean, avoid using these natural keys unless they are highly permanent. If they are permanent, then only we are supposed to use. So when we designing the schemas, we need to understand the candidate, composite, alternate, and super keys. These four categories are used while designing these schemas. So why we need to know all these keys? Because when we know the different types of keys that are available and essential, and these are essential for designing a clean and good databases. When we design a database, these will play a major role. So let's get started into our next event. So what is an SQL? What is an SQL architecture? How does this work? What happens behind the scenes? So when you run an SQL command, you select all from users. You may feel that you get the data instantly when you type the query and send the query, but there is a whole system working under the hood. So let's break down this architecture so that you will understand how these databases are, especially SQL or Oracle or whatever the database may be, it actually process your queries. So what is SQL? It's as we discussed yesterday, it's just a language, but it interacts with this database management system, which has multiple layers of working together. So we have this relational engine, protocol engine, and storage engine. Like on a simple words, it accepts your query and it understands it, it executes it, and it returns the result. So this is how this works. Like the user sends a query and the user will be authorized, and if you have any sensitive data, and then it translate the query conditions and modify the query conditions if necessary, and then it will create a hash value like a binary, like some algorithm, let us say an algorithm or a binary value. That is how computers communicate with each other. So then it will execute the query. So what really happens between these is, so there is this query interface, or we call it as SQL parser. So this is the entry point. This is the entry point where we get all this information, right? So where we get all these information, like, so let us say you type something like select all from employees where the department in sales. So it first go through this query processor, and this part checks if your syntax is correct or not, and then it breaks the SQL query into a number of tokens. So based on these tokens, it converts into a structured called a parsing tree. So a parsing tree. So what this parsing tree does? So it usually checks your query, and it is how the database management system understand your input. And then this query optimizer. The query optimizer, once this SQL parser completes its work, it goes to the query optimizer. It's a very important layer. Its job, the main purpose of this query optimizer is to get the fastest and efficient way to execute your query. For example, if you have your employee table for more than a million rows, the optimizer will choose the best index. So since we filter with department sales, so that department column might have an index, and it avoids scanning the 1 million rows, and it scans only that particular sales department, and it will reorder the joins and filters to get the details very faster. Even if two people write different SQL queries, this optimizer might generate the same execution plans. The intent is the same. Like, let us say you want this department sales, and another person is also on department sales, but he want a particular column and you want another particular column, so the intent might be the same, it is almost the same, right? So that is how this query optimizer works. So then what is this query executor? So now the query is ready to run this execution engine. So whatever we call it here as execution engine, so this execution engine, it takes the optimized plan and starts interacting with the storage engine, right? So it will interact with storage engine and transaction manager, and there will be a buffer manager. So these are the different parts that we have in the in this architecture. So it fetches the data from the disk or from the memory. If it is in memory, it takes from the memory, and it applies all the conditions, and it performs and returns the result. So this is where the real work happens. Everything happens in the execution engine. So in the latest technologies like Spark, distributed computing, we have these execution engines, multiple execution engines. So mostly in traditional SQL, we have only single execution engine, which is powerful enough to get all our data, right? So then what is the next part? It's the storage engine. So this storage engine, it manages how the data is physically stored and retrieved from this disk or memory. So it handles the tables, the indexes, the files that we have over here. It it also, you have to remember that it also tracks where each row lives. Based on that, it will extract those data. So what is the use of this? So most popular systems like this MySQL or other databases, we have different types of storage engines like RDB, MyESAM. Like, these are some of the examples which you don't need to know right away. So you can know these things at a later point of time. But based on our needs, you can choose this. Okay, so then the final portion. What is transaction manager and a buffer manager? So this transaction manager ensures that your queries follow the ACID properties. We'll be doing a separate video on this ACID properties. It's a big topic. All these SQL databases, these follow this ACID transactions. So your data stay consistent even if you have an error, so you don't lose your data anytime. So, and what is this buffer manager? This buffer manager reduces disk rates by catching the data frequently accessed. So what does this mean? So let us say you are acquiring the employees table multiple times. Instead of going every time into the storage and grab the data, it stores the same data in the memory, which we say as caching. So this buffer manager is responsible for that. This makes these SQL databases both reliable and efficient. So let's get into this. It's very simple. So you type your query, it go to the parser, it go to the optimizer, it go to the executor, and then storage engine, and then to data, and finally it gives the result back to you. So how these layers are designed? So each layer is designed to make sure your query is valid, efficient, safe, and fast. this is how your query runs behind your thing. So what are the latest how the latest things work? So in the latest databases, which we called as distributed databases, each data is distributed across a different node. So when we query, your query will be break down into some parts. Example, the Synapse Analytics, your query will be break down into 60 equal parts. Each part will be responsible for gathering information, like that. Right. So this is how the SQL architecture works.